Yeah, you're welcome back again. Good everyone. We're back again for a very interesting maths class today. I want to appreciate everyone who actually sent in the very beautiful comments over the last topic we treated. And I want to promise you that we're going to continue to deliver qualitative teaching here as long as you continue to spread the message across so that we can have a wider reach of students watching our videos. Today we're going to get into a very new topic, and the topic that you're going to see in the senior secondary section, we have laws of indices. But first of all, let's get into it. We have indices. Indices is actually the plural form for index. The word indices, that's the plural form for index. Plural form for index. We're going to be very fast so we could cover a good number of grounds. Now, what does the word index mean? Another word that could be used to describe index is power. Some persons also refer it to exponent. Exponent. Good. So, invariably, what we are talking about today is laws of powers or laws of exponents. Now, what does power mean? Power. The power of a number is usually the number of times a number is used in multiplication. The number of times a number is used in multiplication. We'll do a little bit on this. What do I mean? And that number is generally referred to as the base. We call that number that we usually make a reference to, we call the number the base. To represent the power of a number, so let me assume I have 2, which is the number, and I write a small value on top of that number. This small value here I have written is what we call power. While this 2 here is the one we refer to as the base. So to pronounce this, we say 2 raised to the power of 3. This 3 tells you the number of times you are going to multiply these 2. This means 2 times 2 times 2. Many students always assume that this is the same thing as saying 2 times 3. Please, this is wrong. The power of a number is the number of times you are going to use the base in multiplication. That's what we call the power. So always take note that the value or the number we have here, in which that is raised to a power, is usually referred to as the base. Now, why do we have laws of indices? There are times you are going to be confronted with certain problems like 2 raised to the power 3 times 2 raised to the power 4, and you see that expanding this is going to give you 2 times 2 times 2 times 2 times 2, and so on and so forth. The stress of writing 2's and then running into the error of even counting and making mistakes led to the introduction of laws of indices. So in this class, we're going to go through the 6 laws. We have 6 laws of indices, and many of these questions that turn up here always show up in exams, especially in your WAEC and NECO exams. So we're going to take our time to look at those laws. The first law, law 1, we are not going to be speaking too many grammar here. We'll just go straight to the point and then attack it the way it should be. The first law says, when you have a number raised to a power and is being multiplied by another number that is raised to another power, they must be of the same base. So when 2 numbers of the same base are being multiplied together, rather than doing this 2 times 2 times 2 times 2 times 2 times 2 times 2 to give you 2 raised to power, of course you have to count the number of 2's you have here, 1, 2, 3, 4, 5, 6, 7, to give you 2 raised to power 7. Law 1 says, just write down the base, which is the number, and add the powers. So I'm going to have 3 plus 4, and my answer is 2 raised to power 7. You can see we've gotten the same thing. So it reduces the stress of having to expand the base, the number of times you have there as your power. What is law 2 saying? Law 2 says, very similar to the first law as well, that when you have a number or two numbers, now we're talking about the division law, raised to a power and they are of the same base, we'll have 2 raised to power 2, for instance. Rather than doing 2 times 2 times 2 times 2 all over 2 times 2, so you would have to cancel out and you're left with 2 raised to power 2. The law says just write 2 as the base and then subtract their power. So we're going to have 2 raised to power 2. Now, law 3 says when you have a number raised to a power and that number is also raised to another power, rather than doing this, because this is going to be 2 raised to power 2 times 2 raised to power 2 times 2 raised to power 2, this is 2 raised to power 2 into 3 places, and then you would have to do 2 times 2 times 2 times 2 times 2 times 2 to give you 2 raised to power 6. The law says write down the base and then multiply the powers, 2 times 3, which will give you 2 raised to power 6. Let's go over to the other side. So I have, let's see what we have there. I have the law 4. Law 4 says, let's clean this. It's a bit of a problem. Law 4 says the value of a raised to power 0 is 1. That is, anytime a number or a base is raised to the power of 0, your answer is 1. Take for instance, 2 raised to power 0 is 1. 1000 raised to power 0 is 1. And how do we prove that? We prove that from the second law. If you have 2 raised to power 4 divided by 2 raised to power 4, using the second law, it means that our answer is supposed to be 4 minus 4, which is 2 raised to power 0. Isn't it? So if we have this as being 2 raised to power 0, what it means is, if this law is applicable, then this is also going to give us 1. So whenever you raise a number to the power of 0, always know that it is going to drop 1. It's as simple as that. So we have law 5. Law 5 says the law that has a negative power, whenever you have a number raised to a negative power, do everything possible to remove this negative power. And how do we remove a negative power? Just invert the base and the power will change. So this number is the same thing as saying 1 over a. Remember that there is a denominator here that is not seen, raised to the power of b. Once you invert a base, the negative power automatically disappears, which means if I have 2 raised to the power of minus 3, my answer is, make sure you remove this particular negative sign. I always tell students, don't work with negative powers. So this is going to be 1 over 2 bracket raised to the power of 3, which invariably will now turn out to be 2 raised to the power of 3. This is 1 times 1 times 1 all over 2 times 2 times 2, which will give you 1 over 8. Now let's get into the 6th law, which is the final law. Let's also assume I have, for instance, here now, 2 over 3 raised to the power of minus 1 over 2, for instance. What this is going to give me is, remove this negative power by inverting this. So we're going to have 3 over 2, all in bracket, 1 over 2. Now the 6th law, which is the final law we're going to consider today, the final law we're going to consider today is the law for the fractional index. We have, when you have a number or a base that is raised to a fractional power, your answer is the denominator root of that number. Just take the denominator root of that number, put a inside the root symbol, and then use the numerator as the power. For instance, 8 2 over 3, just take the denominator root of 8 raised to the power of 2. So this is going to give us that cube root of 8 is 2 raised to power 2, which is 4. So cube root of 8 is asking you to find out a number that you're going to multiply 3 times to give you 8. So today we have just talked about the laws. We're going to have time to now review questions and use questions to buttress what we have done today. I guess you enjoyed the lesson. We're going to have more time to solve questions based on these laws. But take time and understand all these laws and find time to share. Follow us on all social platforms and be excited about what we are doing. Thank you for joining us.